particle P moves along a straight line and its acceleration when it has a displacement of x meters from O, a fixed point in the line, is of magnitude 8x meters per second squared and directed towards O. So that means if O is here and the particle is here, that the acceleration is actually directed back this way. In other words, A is going to be negative 8x. We're told that V is 0 when x equals 2. And in part A, we want to obtain an expression for V squared as a function of x. So acceleration is negative 8x. So V dV dx is negative 8x. This is a separable differential equation. Integral of V dV is equal to the integral of negative 8x dx. So V squared over 2 is going to be negative 8x squared over 2, and for convenience I'll call this constant over 2. So V squared is going to be C minus 8x squared. We can now use the information here. So V is equal to 0 when x is equal to 2. So 0 is going to be C, take away 8 multiplied by 2 squared. 0 is C, take away 32, so C equals 32. So V squared is going to be 32 minus 8x squared. We want to find the values of x for which V is 0. So if V equals 0, of course, that means that V squared equals 0. So 32 minus 8x squared is equal to 0. 8x squared equals 32, so x squared equals 4, giving us that x is equal to plus or minus 2 meters. Then in part C, we want to find the maximum speed of P. So V max would mean that dV dt is equal to 0, which of course means the acceleration is equal to 0. Now A is equal to negative 8x, so that means when x is equal to 0. So V squared, or V squared max, is going to be equal to 32. So that means that V is going to be plus or minus root 32. And we can write 32 as 16 times 2. So that's going to be plus or minus 4 root 2. Now of course we don't need to worry about the negative because we are talking about speed. So the maximum speed is going to be 4 root 2 meters per second. Now, although we didn't do the question using any of the formulae, this question is an example of simple harmonic motion, or SHM, which we'll be coming on to later.